guys, so we're gonna have a look at the last question from this past paper. I think we can all agree that yeah, it's been a long day. I'm extremely tired. I've been basically editing the whole day. I've been editing these 5 questions and uploading them consecutively throughout the whole day. So I'm really exhausted, guys. But since you guys are writing tomorrow, I'm just hoping, these are just gonna come in handy for someone out there because I couldn't upload these video tutorials any sooner because I was also writing my own exams. Okay, so I hope these are really gonna come in handy and I hope that they are really helping. Okay, so let's have a look at the last question, guys. And in question 5, I did mention that we are basically going to be interpreting doing map interpretation in this question, and we're also going to be calculating liters needed for trips throughout the whole week and so on and so forth. Okay, so let's basically get started. Question 5.1, it says Noah is a traveling salesman who lives in the United States of America. He uses a map to estimate his traveling time between cities. On an XGD is a partial map which shows the following. The partial map shows the various cities, the distances in miles between the different cities, and then the average traveling times in hours between these cities. Okay, question. Okay, here it says use an XGD to answer the questions that follow. Okay, question 5.1.1 says choose one letter X, Y, W, X, Y, or Z that will make each of the following statements below true. Okay, the first one says that the average time in hours to travel between Lee and Springfield is. Okay, so before we can get answer this question, right, we basically need to have a look at what is actually given to us in an extra D. What is happening? Okay, so let's have a look at an extra D. So we can see here with an extra D, we are basically given a partial map of the United States of America showing distances in miles and time in hours, hours and minutes taken between various cities, right? We're given a key here, right? Where when it's just 2 digits, it's miles, and then when you've got like a semicolon between your numbers, that basically tells us that we are dealing with time. Okay, example to use the key, for example, New York to Lee. Okay, here is New York, here is Lee. Let's just understand what is happening here. For you to move from New York to Lee, we're given that number there at the top, right? So the number there at the top, right, without the colon is just the miles. Okay, then the 3 colon 26, that is the time in hours. So it's 3 hours and 26 minutes. Okay, we're also given a compass here that we can basically use, and it basically indicates that our north is that way. Okay, so I think we're more than ready to have a look at the question. It says the average time in hours to travel between Lee and Springfield is it W 50 over 60? Is it X 50 over 100? Is it Y 0.5? Or is it Z 41? So we need to find out where is Lee and where is Springfield. Okay, all right, and determine the average time in hours. Okay, so let's see, where is Lee here? All right, so we see that is Lee, the city Lee. All right, and where is the city Springfield? That is that, right? And then we are given the time, right? So the time here is 0 hours and 50 minutes. Okay, so now we want to basically determine what is the average time in hours, right? We already know what the average time is in minutes. We know it's 0 hours and 50 minutes. So if you want the average time in hours, right, this is given in minutes. We know that 1 hour is equal to 60 minutes. So for us to convert now these 50 minutes into hours, what do, right? It's basically just going to be multiplied by what you want. You want your units in hours divided by what you have, which is your units in minutes. Okay, so here it'll just simply be 60 minutes. So then here we have now basically found that, okay, you'll see that then the average time in minutes, the correct option here will just be the 50 divided by 60 hours. Okay, so our correct option here is W. All right, let us have a look at question B. Okay, which city lies southeast of Boston? Okay, all right. Is it Providence? Is it Lowell? Is it Chester? Is it Plymouth? Right. So we first need to find where is Boston, and then from there we need to basically determine which city lies southeast of Boston. Okay. So where is Boston? Let's basically try to pinpoint that from our map here. So this is Boston. Okay, so we want to basically determine which city lies southeast. Remember, we're already given the compass here, right? If you already know where your north is, guys, I've been saying, right? All we need to do, naughty, elephant, sprays, water. We move in a clockwise direction, okay, from the north, and then it's naughty, elephant, sprays, water. Where is south east? The southeast is in that direction. Okay, so that is our southeast direction. So basically now we're going to move this line parallel. Okay, we're going to move this line parallel to determine now which city lies southeast. So I'm just going to use a ruler here just to show you guys what I mean by that. Okay, right? So if you basically move this ruler parallel to the southeast, what do we see? Okay, that is our Boston there, right? We've already pinpointed where Boston is, right? So from Boston, we want to determine which city, okay, lies southeast. Okay, so from here, guys, we can basically see that, okay, the city, okay, so if we basically move our ruler parallel here, we see that the city that actually lies southeast to Boston is Plymouth. Okay, do you see that? Okay, all right, the city that lies southeast is what? Plymouth. Okay, all right. Okay, so that basically says that the option that we are going to choose for number B is Z. All right, let us have a look at question 5.1.2, right? So let's just quickly write down these answers nicely. Okay, 5.1.1, we said our answer here is W. Okay, and then this is 5.1.1a, answer is W, and 5.1.1b, our answer here we said was Z. All right, let us continue. 5.1.2, Noah found that the same time 105 is estimated for traveling from Providence to Boston and from Springfield to Worcester, right? So write down the actual distance in miles from Providence to Boston and from Springfield to Worcester, right? So we want to write down the actual distance in miles from these cities. Okay, so we need to find out where is Providence and where is Boston, and then we're gonna find out where is Springfield, where is Worcester, and then we're gonna now write down what the actual distance is in miles. Okay, so we're gonna start off with Providence and Boston. Okay, so we see that that is Boston. So we found Boston. Where is Providence? Providence. That is Providence, right? So what is the distance in miles from Boston to Providence? Do you see that the distance there is 52 miles? Okay. Then we need to find the distance from Springfield to Worcester. Okay. So that is Springfield, the distance from Springfield to Worcester. Okay. So from there, that distance is 55 miles. Okay, so we're going to write that down. That the distance from Boston to Providence is 52. Distance from Springfield to Worcester is 55 miles. Okay, let's write that down. Okay, so the distance from Providence to Boston is 52 miles, and the distance from Springfield to Worcester is 55 miles. Okay, let's continue. This is question 5.1.2a. All right. Okay, let's have a look at the next question. Question 5.1.2b. Give one possible reason why the map indicates the same traveling time for these two different distances. Okay, so let's see. Right, so we see that, okay, from Springfield to Worcester, the traveling time is 1 hour and 5 minutes. Okay, from Boston to Providence, the traveling time is 1 hour and 5 minutes. So why would these two places have the same traveling time, even though we've got different distances? Okay, so something that could actually affect the traveling time right here is that you'll find that maybe, okay, because you find that this one is actually a longer distance compared to that one. So you'll find that maybe here, even though the distance is longer, right, or more, right, the traveling time basically stayed the same, because you'll find that things that affected the difference in the time, where you'll find that with one, even though it's a larger distance but the time is still the same, is that you'll find that maybe you were traveling like on the road, and on the other one you're probably traveling on gravel. That would then affect maybe how fast you are moving through that terrain, right? So we can basically write that as a reason, maybe probably conditions of the road. You'll find that maybe one is gravel, and maybe one was like your normal roads. That could affect your traveling time. Or you'll find that maybe what could also affect the traveling time was that maybe in one road there was traffic, and in the other one there was no traffic. Okay, so we can write any of those reasons or any other reason that would make sense. Or you can also even think of traffic lights. Okay, traffic lights will also affect, could actually even affect maybe the time that you would spend on the road. Okay, you'll find that maybe here there wasn't as many traffic lights, and maybe in this side there were a lot of traffic lights. Therefore, even though you had a longer distance, but then the time, so even though here you have a shorter distance, but because maybe you had a lot of traffic lights, it actually affected the time. So maybe the time adds up to that same time that you would have there. Okay, so I hope you guys get what I'm trying to say here, that what would actually affect, what would cause these two distances to have the same time but different distances. Okay, so those are the different reasons that you could basically write. Okay, let's write them down. Okay, so the conditions of the road could basically be the reason why they would have maybe the same traveling time but different distances, or the conditions of the road. Okay, that could also affect how fast or how slow you drive through your road. Okay, so that is that with question 5.1 and question 5.1.2. Okay, let's have a look at the next question. Question 5.1.3. It says Noah traveled from Portland, passing three cities A, B, C, in the table to reach his destination city D. Okay, table 1 below shows the time taken to travel between various unknown cities indicated by A, B, C, and D. Okay, so the start city, okay, We are given the destination city, and we are given the time taken between the cities. Okay, so it says name the cities A, B, C, and D. Okay, so if he starts at Portland, okay, what is the destination city A? If it takes him 1 hour and 35 minutes to basically go through that city. Okay, so we're gonna have a look at our map here, right? We're gonna try and find where is Portland, and if he basically starts at Portland, we're gonna see which city does he, what is the destination city that he lands at if he basically traveled for 1 hour 35 minutes. So this is Portland, guys. You can see it's there, right? So if he travels for 1 hour 35 minutes, we see that, oh, the destination city is the Newburyport. Okay, so we're gonna basically write that down. Okay, so we already said that A is basically the destination is actually Newburyport. All right, let's have a look at what's happening with B. Right, so with B, we're going to basically move from Newburyport and we're going to go to our destination B, and it takes us half an hour to get to our destination B, guys. Okay, so what is half an hour? Half an hour, guys, is half of 60 minutes, and half of 60 minutes is equal to 30 minutes. So we're going to look for 30 minutes. So we are basically at Newburyport now, right? And we want to find the destination that's going to take us 30 minutes. Do you see that? It's that destination there, right? It's that one there. So that means that we're moving from Newburyport to Lawrence, okay? So it takes us half an hour for us to move from Newburyport to Lawrence, okay? So we are basically going to write that the destination B is therefore Lawrence. All right, what is happening now? For us to move from Lawrence to destination C, we are told that it takes 35 minutes, okay? So we're going to basically go to our map now. We are going to look for a destination that's going to take us 30 minutes to get to, right? 35 minutes to get to. So from here, we see that for us to basically move from Lawrence to Boston, do you see that? We see that we are given that 35 minutes there, okay? It takes us 35 minutes. So then the destination city, C, is Boston, okay? And the last one, we're going to look for from Boston, we're going to move to destination D, and it takes us 1 hour to get to that destination, right? So we are going to basically check here for a destination that's going to take us 1 hour to get to, right? So from here, guys, you can see for us to move from Boston to Worcester, right? It basically takes us what? It takes us what? 1 hour. So the destination D is actually equal to Worcester. All right, and we are practically done with question 5.1.3. Okay, we've basically named all those cities there, right? Let's basically have a look at question 5.1.4. Question 5.1.4 says the fuel tank of Noah's car has a capacity of 23 gallons. Okay, so his fuel tank can basically hold 23 gallons of fuel. Okay, Noah claims that in South Africa it will cost him less than 1,400, okay, to fill up his fuel tank to capacity. Okay, we are basically told that 1 gallon is equal to 3.785 liters. We are told that the fuel cost is equal to 15 rand and 97 per liter. So 1 liter is equal to 15 rand and 97. And then we need to now verify whether his claim is correct. Okay, so basically this is his fuel tank. Okay, it can hold 23 gallons. Okay, and he is basically claiming that it'll cost him less than 1,400 to fill up his fuel tank. Okay, so all that we now need to do, we're going to take this 23 gallons of fuel and we now have to convert them to liters. After we've converted these gallons to liters, then we will be able to determine how much is Noah going to pay for the liters of petrol. Okay, so that's basically what we're going to do now. Okay, this is question 5.1.4. Okay, so his tank can hold 23 gallons. Okay, so we want to convert these gallons into liters. Okay, how are we going to do that, guys? We are going to basically use this equation that is given to us, that 1 gallon is equal to 3.785 liters. Okay, so we're going to do what? Multiply by what we want, and we're going to divide by what we have. Okay, so we're going to take these 23 gallons, okay, and we're going to multiply by what we want. We want the units in liters. So we're going to take the 23, multiply by the units in liters, which is 3.785 liters, divide by what we have, which is our units in gallons. So it's 1 gallon. Okay, then you'll see that, okay, the gallons will cancel. Therefore, okay, 23 gallons in liters is actually equal to 87.055 liters. Okay, so now we're not done. We still need to convert these liters into how much he now needs to pay. Remember, we were told that, okay, here the fuel, 1 liter of petrol, is actually equal to 15 rand and 97 cents. Okay, so we already know that 1 liter of petrol is equal to 15 rand and 97 cents. So we're going to have to convert now these liters into how much he basically pays for petrol. Okay, so it's going to be 87.055 liters multiplied by what you want. You want how much he will pay, the cost for his petrol. So it's going to be 15 rand and 97 divided by what you have. We've got our units in liters, so it's going to be 1 liter. Okay, then here, guys, honestly, at this point, I just feel like I'm just like a record that's playing itself over and over again. Okay, you should see that now the units for your liters, they cancel each other. So if you punch this into your calculator, 87.055, if you multiply it by 15.99 divided by 1, you will get that he actually pays 1,392.00945 rand for petrol, which is approximately just 1392.01. Okay, that is how much Unoa basically pays for his petrol. Okay, so what was his initial claim? What was he saying? He was basically saying it will cost him less than 1,400 to fill up his fuel tank. So from this we can actually see that actually his claim was valid. Okay, all right, and that is it. Question 5.1.5 says that Noah stays in Greenfield and travels to Fitchburg. Okay, so he stays in Greenfield and he travels to Fitchburg. Okay, and back. Okay, from Monday to Friday. He fills his car's fuel tank on Monday mornings. Okay, the fuel consumption on his car is 18 miles per gallon. He refuels his car to capacity as soon as he does not have enough fuel to complete a trip between the two cities. We now need to determine the number of gallons of fuel left in his car on arrival in Greenfield on Friday afternoon. All right. So with this question, obviously it's a bit tricky, right? You basically need to first determine, okay, with this question, okay, how many miles one full tank of his car covers, okay? Once we've basically determined how many miles one full tank of his car covers, right? Then we will be able to then determine how many trips can those miles make. Okay, once we are able to determine how many trips those miles can make, right, we can determine which day, for how many days actually his petrol will last him. And once we've basically determined how many days his petrol will last him, we will be able then to determine the number of gallons. So let's just actually build this question up so that I do not lose anyone. Okay, I'm gonna do this question here at the bottom. Okay, this is question 5.1.5. Okay. Okay, so the first thing we know that, okay, one full tank, okay, of his car is equal to 23 gallons. Okay, we were given this information, okay, that the fuel tank of his car has a capacity of 23 gallons. Okay, so from these 23 gallons, guys, right, we basically want to determine how many miles, okay, can that fuel cover. Okay, and we are given the rate that will help can help us calculate the miles. We are told that the fuel consumption of his car is 18 miles per gallon. So we're going to use this equation to help us now convert these gallons into how many miles will a full tank take you, okay? Or give you, okay? So we're going to basically now take this equation and we're given that it's 18 miles, okay, per gallon. What does this mean? It basically means that 1 gallon, okay, will basically give you 18 miles. So you'll be able to drive 18 miles from 1 gallon. So we're going to basically use this equation to help us now convert these 23 gallons into the miles that a full tank can cover. Okay, so we're simply going to just use this. It's going to be 23 gallons. At this point, guys, this should be super easy. Okay, you multiply by what you want. Okay, you're multiplying by the miles. We want to determine how many miles can a full tank cover. Okay, so you multiply by 18 miles and you divide by what you have, okay, and you just have your units in gallons, okay, so it's going to be 1 gallon, okay. Then here you'll see that your gallons cancel, the units for gallons cancel, and you'll just be left in your units in miles, okay. So if you punch that into your calculator, you will find that, okay, 23 gallons of fuel will basically travel 414 miles. So that is basically the distance that can be covered by 23 gallons. Okay, that's just the first step of this question, right? So now we need to determine, okay, how long is one trip, okay, right? Because yeah, we need to basically determine how long is one trip. So we already know that he travels from Greenfield to Pittsburgh, okay, so we basically have to look at this map that is given to us, and we need to find where is Greenfield, that is Greenfield, where is Fitchburg, that is Fitchburg, what is the miles between these two cities, it's 49 miles, okay, so it's actually equal to 49 miles. So for one trip, he travels 49 miles. Okay. So one trip, okay, when he just goes to from Greenfield to Pittsburgh, he just travels 49 miles. So one trip is equal to 49 miles. Okay, how is this going to help us with anything? Okay, this is basically going to help us determine how many trips can we get from that 414 miles. Okay, so now we're basically going to now use this new equation that we've basically obtained to help us now determine how many trips can we get out of this full tank. Okay, so we're just going to take that 414 miles, then you multiply by what you want. You want to determine how many trips can I get from this full tank. I'm going to multiply by 1 trip, right? Okay, and then I'm going to divide by, okay, what do we have? We've got a unit in miles, so it's going to be 49 miles. Okay, so from here, what is it that we see? Just see that our miles cancel, and whatever answer that we will now get here is basically going to tell us about the trips that we are going to be able to make from a full tank. So if you punch it into your calculator, you'll get that you can make 8.448979592 trips. Okay, so you can make a total of that number of trips. However, guys, okay, we're not going to be making 8.4 trips. Okay, we're going to either be making 9 trips or 8 trips. Okay, so in this case, we will just say it's a total of 8 trips. We can't overestimate. Okay, right? We are just going to make 8 trips. We're going to round down. Okay, so that basically means that if he now travels from Monday to Friday, right, and a full tank only will give him 8 trips, right? When will he now have to refill, right? And then how much petrol will he have left on Friday? That is basically what the question is asking. So this question is a bit of a mouthful, okay? But let's see. So on Monday, when he goes to Pittsburgh, okay, it's actually 1 trip, but when he comes back, it's 2 trips. So on Monday, it's 2 trips. On Tuesday, it's 2 trips. Okay. So on Monday, it's 2 trips. Tuesday, it's 2. Wednesday, it's 2. He goes and he comes back. Thursday goes, comes back. Friday goes, comes back, right? He can only make 8 trips. So that means that his petrol will only last him until when, right? So it's going to be just 2, 4, 6, 8. His petrol will only last him until Thursday. Okay, so that means that now on Thursday he will basically need to fill up his car again, right? And if he fills up his car again, that means that on Friday he will only use 2 trips. Okay, meaning that he will basically use, okay, on Friday, right, he will basically use 2 trips. Okay, and then we already know that 1 trip is equal to 49 miles, right? How can we get 2 trips? 2 trips, you just multiply by 2, right? Therefore, 2 trips is equal to your 49 multiplied by 2, okay, right? And then that will give you your answer in miles, right? Therefore, okay, for 2 trips, 49 multiplied by 2, it's equal to 98 miles. Okay, so now from these 98 miles that he's going to use on Friday, right? We now need to basically determine how many gallons of petrol that is, right? And then from there we will be able to determine how much petrol he will have left in his tank. Okay, so how can we determine the gallons? Remember, guys, we're given this equation that 18 miles is equal to 1 gallon. So we're going to use this equation again. Remember, we just wrote it like this. We're going to use 1 gallon is equal to 18 miles. Okay, going to use it again. 1 gallon is equal to 18 miles, right? Then we're going to convert now this 98 miles into gallons to determine how much then petrol did he use for the 2 trips on Friday. So we're going to take that 98 miles, right, multiply by, we want how much petrol he used, so multiply by the gallon divided by the miles of 18, right? If you punch that into your calculator, you'll see that obviously here the miles are cancelling. Whatever answer we have, it's going to be in gallons, okay? So if you punch that into your calculator, you'll see that, okay, actually, right, on Friday, Noah just used 5.44444 gallons of petrol. Okay, so how much petrol does he then have left? Okay, after he's used that, we already know that his car basically uses 23 gallons of petrol, right? Then we need to minus the 5.4444 gallons that he used, okay, to tell us that he therefore has 17.56 gallons of petrol left, right? So yeah, this question was one of those questions that were like a bit of a handful. Okay, you really just need to focus and try to figure out what is this question asking for you guys, from you guys. It says determine the number of gallons of fuel left in his car. So that is basically the process that you need to follow to help you determine the number of gallons. Guys, let's have a look at the last question and we are going to call this a wrap. Okay, question 5.2, we're basically going to be converting your degrees Celsius to degrees Fahrenheit, okay? So we are obviously given here a temperature reading of -7 degrees was displayed on the screen on the dashboard of Noah's car. We need to determine to the nearest 10 the temperature in degrees Fahrenheit. We're given the formula that we're supposed to use. Here, guys, it's very simple. We are just going to be substituting our known values and then we are just going to isolate the F, okay? So I'm just going to rewrite the formula here, right? So we want to convert your -7 degrees Celsius. We're given the formula degrees Celsius is equal to 5/9, okay, multiplied by degrees Fahrenheit minus 32. Okay, so here I'm going to just start off by just isolating the F initially from this equation. Okay, so how can I basically get rid of this here? This is basically us just saying, it's the same as just us saying it's 5 times it by degrees Fahrenheit minus 32, right, divided by 9. Okay, this is basically the same thing. Okay, then how do I get rid of the 9 on the right hand side as well as the 5? You multiply by its reciprocal, so 9/5. Then the 9 cancels, 9 cancels, the 5 cancels, 5 cancels. What you do on the right hand side, you also need to do on the left hand side, right? Meaning that now on the left hand side, you've got 9/5 degrees Celsius is equal to degrees Fahrenheit minus 32. That is what we now have on the right hand side. We still just want to isolate this F. So to isolate the F, what do we need to do? You basically need to do the inverse of subtraction. So you're going to plus by 32. If you plus by 32, you also need to plus by 32 on the left hand side. So you're going to plus by 32. Therefore, it's going to be 9/5 degrees Celsius plus 32 is equal to degrees Fahrenheit. Okay, so here now our equation is nice and easy. We will be able to then substitute the value of the temperature in degrees Celsius into our formula to get what the value is in degrees Fahrenheit. So it's going to be 9/5. What is the temperature? -7 degrees Celsius plus, let's just leave it as -7, okay, plus 32, which is equal to degrees Fahrenheit. If you punch this into your calculator, you'll get that the temperature is 19.4 degrees Fahrenheit. However, The question asked us to round this off to the nearest 10. Okay, so if we're rounding off to the nearest 10, we're going to be looking at the units for the 1. That is the unit for the 1, and the unit for the 1 is a 9. That means that we are basically going to round up, and that is approximately equal to 20 degrees Fahrenheit. Okay, so that is the final answer for this question. And guys, we are finally done. I am exhausted. Yeah, it's been a lot. Okay, but that's all, guys. I really just wanted to help you guys, and I hope you guys are still up. If you guys aren't, I know that some of you are gonna check this out in the morning, and I hope you guys really enjoyed the video tutorials, guys. Yeah, it took a lot from me to record this one. Okay, it's the first time actually just finishing a whole tutorial in one day. All right, guys, so I'll see you guys on my next upload. Good luck with your exams, guys. All the best, and thank you so much for watching the video tutorials. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.